Hello, everyone. I'm Ipsha Bhidonia. I come from India, where I work in the domain of digital security as a software engineer with Gemalto. I am also very closely related to Mozilla since a couple of years now. So I am a part of their technical speakers community and a mentor for their open leadership program. Today, I stand here to talk about something that is close not only to Mozilla, but to all the major browser makers like Google Chrome, Microsoft Edge, and etc. So we'll basically be discussing about what progressive web apps are, how they are different from normal web applications, what technologies lie at the core of PWAs, and how it all works so seamlessly well, especially from a perspective of a user experience. Today is a great time to be building something for the web. It's the largest platform ever, and we are seeing tons of development practically on a daily basis. We have over 5 billion devices connected to the web, so you can imagine what a huge impact it has in today's world. But with great power comes great responsibility in terms of providing best experiences, high performance, least friction for the users using your application. This is where PWAs come into picture, the technology that has revolutionized the mobile web apps. Now, when we talk about applications, we majorly talk about two platforms, the web and the native. And there's always been a tug of war, so to say, in deciding where to invest your time, effort, and money. No doubt it depends on the use case you're building your application for, but at the end of the day, we are seeing more and more applications being built on both the platforms. So how do you decide? The web and the native are like the flora and fauna of an ecosystem. They both are equally essential to sustain the ecosystem, and we just cannot thrive with either one of them because they both have their own roles to play, right? So when we talk about the web is known to have a greater user reach. And when it comes to the native is known to have a greater user engagement. For instance, think of an example where you want some quick information off your mobile device. You'd most likely use your mobile browser to get the information because you might have an app for certain things, but you do not have an app for everything installed on your mobile device. That's why we see the mobile web reaching over 2 times as many people as the native does. However, when it comes to user engagement, people are more likely to use a selective few apps that they really like and that aligns with their interest over a long period of time. Hence, we see that the native apps are better in engaging users. But when it comes to progressive web apps, we sort of get the best of both worlds because these are experiences that combine the best of web and the best of natives. So now, to be qualified as a progressive web apps, there are a bunch of feature and checklist items that your application must satisfy to be qualified as a progressive web app. So let's just quickly go over a few of them. So as the name suggests, progressive web apps are progressive in nature, which means that the basic content and functionality of these apps work for every user, regardless of the browser choice or the bandwidth, while at the same time providing an enhanced version of your application to those users with better connectivity or a modern web browser. These feel app-like because they are built using the app shell model that separates the content and the functionality. So you have a basic skeleton that is instantly loaded, which provides a better user experience. They are linkable in nature in the sense that you can link your application to a specific URL, so there's no app store required, no complex installation process. It's just a URL, you can use it at a go. They are discoverable in the sense that they are identifiable as applications by the browser, so they can find them, rank them, catalog them, etc. One of the major differences that progressive web apps has is that in addition to most web applications, these are enhanced with service workers that provide them with modern web capabilities like providing offline experience and push notifications. So this makes your app independent of the connectivity in the sense that it will now work not only in flaky but also non-existent network. At the same time, you can greatly re-engage your users by sending timely updates and push notifications directly to their devices even when they're not using it, just like native apps do. Like any other modern web app, they are responsive in nature, which means that following the content is water philosophy. They are designed to fit any form factor, mobile, desktop, tablet, or whatever is next. Since they are built using service workers, which are served only over HTTPS, they are extremely safe and prevent snooping. But the really cool part about progressive web apps, though, is the add to home screen feature. So these are basically applications that starts as a URL, but they eventually evolve into top-level immersive standalone applications that leverages web's low friction, which means that once you start using enough of the web application, you'll get a prompt to add to home screen, using which you can launch it directly from the home screen, just like any other standalone application. This makes it look like and feel more like a native mobile app. For instance, take for example, Twitter. Twitter Lite, when they introduced their progressive web app, if you start using enough of the application, you'll be prompted this add to home screen button, using which you can add the icon directly to the home screen. This is made possible with the web app manifest file, which is basically a simple JSON file that contains different attributes like background color, display mode, description, icon, etc. Basically, whatever you want your users to see as your application icon. And you can also specify how you want the users to launch it. So once you have an icon set, you can render it in a standalone mode. And this is honestly so much better than what we were offered earlier, the open an app or continue an app interstitial that would ask you to download the application before you could continue browsing through. There have been studies that show that people would rather abandon than continue on the site or even download the application. There's a very interesting study by Google related to this that I like to share. It's about leveraging web's low friction. So they say that in consumer mobile app, each step to download an app reduces 20% of the users. When we talk about native app installation, there are a lot of steps involved in installing the app. You go to the App Store, you find the right app, download it, install it, accept permission, and then start using the app. However, with progressive web apps, you reduce the steps between discovery of an application and getting it to the home screen, thereby eliminating the friction of installing an application. This provides a very fertile ground for businesses to pitch in their PWAs. And the best part is that since there's no app store involved, it eliminates the cost and effort of packaging and deploying applications. So having all these engaging features of the native combined with the low friction of the web, these applications are aptly described as websites that took all the right vitamins. Now, when we talk about progressive web apps, one of the major discussion is around the use of service workers. Service workers are important to progressive web apps because most of the features that we just saw, like offline experiences, push notifications, or background sync, are possible because of service workers. They form the backbone of a progressive web app. So to start off, service workers are simple worker scripts that run in the background, and they come with the ability to do two things the best: intercept network requests and cache responses. So a more formal definition of service worker would be that they are a persistent, fully asynchronous, separately threaded event-based worker, which are a lot of words. So let's take them one by one. Persistent, as in they live outside the browser tabs and know when to expire. They are separately threaded like any other web worker. They do not die when the browser tab is closed. They run in their own global script context. They are asynchronous in nature because they make heavy use of promises and hence are non-blocking. They are event-based because they are not controlled by the main thread and they respond to events like fetch, push, sync, etc. So how does a service worker work? Service worker essentially acts as a client-side proxy server that sits between your application and the browser. It takes the form of a JavaScript file, and it can control the pages or sites that it is associated with by intercepting and modifying navigation and requests, and gives you complete control over how your app behaves in certain situations. Jeff Posnick from Google describes them as air traffic controller. As an air traffic controller, service worker gives you control over each and every web request that is made from your site. In the same way, like an air traffic controller may redirect a plane to a different airport or delay a landing, a service worker enables you to redirect requests or even change the response. Let's look at the life cycle of a service worker. It mainly consists of 3 steps: register, install, and activate. So once you register a service worker with your browser and install it, there can be 2 cases. Either it's a new service worker or it's an updated service worker. If it's a new service worker, it goes straight to activation. However, if it's an updated service worker, you'll have to wait for the older service workers associated with different pages to close all the pages before you can activate the new service worker. Looking into more details of each step, the first step being registering a service worker. So it starts by examining the support of service worker in any browser using navigator.serviceworker. The service worker is then registered using serviceworker.register, which returns a promise that resolves when a service worker is successfully registered. You can then log the scope using registration.scope, which basically determines what all files your service worker can control. Excuse me. Next up is installation. This is the step where we cache all the resources that we might need for offline experiences. So this is how we do it. We add an event listener to the install event, and we use caches.open and caches.addAll to add all the assets that we want to be present there. Now, both of these operations are asynchronous in nature. That's why we use event.waitUntil. And if any of the resources fails to get updated in the cache, the installation would fail. Now, once you have a service worker that is ready to control the clients and handle functional events like push and sync, we get the activate event. This is the ideal place to do all that which we couldn't do when the older service worker was in use. So we can delete the cache and migrate database related to the older version of the service worker at this step. So we are basically filtering the cache using the cache name and deleting the resources stored with that particular cache name. This ability to cache the files using a service worker is what forms the background of providing offline experiences in progressive web apps. So because the internet could be flaky or even non-existent at time, running a progressive web app in offline mode, we can still browse the previously viewed items. This has a huge benefit in the market as well. For instance, take for example Flipkart, which is India's largest e-commerce website. This is their way of showing that you're browsing in the offline mode. They basically gray out everything so that you know that you're not connected to the internet, but still you can load the pages that you have previously viewed. Flipkart Lite claimed that this resulted in a 70% increase in their conversion rate. So the general idea is that when you're online, you go to the backend. When you're offline, you go to the cache. But this same concept can be used to enhance and improve the performance somewhat like this. Before approaching the network, we go to the cache and load any saved response. If we do not have any saved response, then we fall back to the network. When we talk about offline, there's an additional step to this. We go to the cache. If we don't have any response, we go to the network. Being offline, there's no network. So we fall back again to the cache where we can load a predetermined HTML or anything that you have decided to show in case of offline mode. So this is the code example to achieve that. You are basically matching the cache with the request. If you have a saved response to that particular request, you load the response. Otherwise, you fall back to the network. And if both of them fails, you just load a response of your choice. So the little dinosaur that we see on Google, that is the equivalent of offline.html here. Now, next really important feature of progressive web app is the push notifications. Push gets its name from the ability to push the data from the server to the user instead of waiting for the user to make a request. Since they use service worker that run in the background, the messages can be pushed to this user even when they're not using the application. So the notifications that you generally get from your native applications on your mobile devices, that is now possible on browsers as well. An oversimplified workflow of this would be something like this. You have a client that registers for push notifications with a push service. In return, the push service gives it an identifier URL, which the client then forwards to the application server. Whenever the application server has a new message, it simply sends the message to the identifier URL to the push service. And the push service then routes the message to the correct client that has subscribed at that particular URL. Now, so we basically have a server that sends a message and a client that receives a message, and a push service that sits between the two of them. So when we talk about service workers being HTTPS only, it means that the communication channel between the server and the push service, and that between the client and the push service, is secure. However, it does not necessarily mean that the push service itself is secure, which is why we encrypt the message at the application server using the client's public key, so that when the message eventually reaches the client, only the client can decrypt the message using its private key. So looking at it in more detail, the first step is subscribing. So whenever you visit a new site on the browser, you might have noticed you get the pop-up of allow notifications. That is basically the first step of push notifications. If you click allow, you're basically subscribing to a push service. Once you subscribe to a push service, you get a subscription object in return. The subscription object contains of two things: an endpoint URL and the client's public key. The client then sends this subscription object to the server, where it is stored whenever any push message needs to be sent. So this is basically a subscription object containing the URL and the key. Once you send it over to the server generates a push message and encrypts it with the client's public key. The server then sends the data to the endpoint URL of the push service, and the push service just routes the message to the correct service worker associated with that particular URL. Coming back to the client side, whenever the service worker receives the message, a push event is triggered. It wakes up and executes the listener associated with the push event. This is where we handle the displaying of the notification of the client side using the notification API. So this is basically the event listener added to the push event. And you can handle a whole bunch of stuff about how you want to display the message at the client side using this. So you can have the body, the icon, and stuff like that. So this is it. This completes the cycle, and you get a real-time web push notification from an app server to the client via service worker. So these were just a few things to show what service workers can do and how we can take the maximum benefit of the web using service worker. Service workers have been undoubtedly one of the best things to have happened to the web lately. And progressive web app being such a huge success, there's no doubt that every major browser is investing immensely in developing support for them. With Mozilla Firefox, Chrome, and Edge being the early adopters of service workers, releasing the support of service workers way back in 2015, Edge and Safari have been lagging behind until recently, which means that progressive web apps weren't supported on a major mobile platform, that is the iOS. This was until March this year when Apple shipped the support for service worker with iOS 11.3. With this news, the last pseudo-argument against investing in progressive web apps have been destroyed. To date, their support exists across all modern browsers, making it a truly exciting moment in the history of web and the native. Progressive web apps have changed how we build and deliver experiences, and with it, an evolution has taken place in the mobile browsers. So let's progress with it, because what's dangerous in business and technology is not to evolve. That's it from my side. If any of this has caught your interest and you'd like to get some inspiration to get started, you should check out these websites, pwa.rocks and PWA stats. They show incredible amount of improvement in terms of performance and other stuff that companies have experienced after trying the PWA route. If the technology resonates with the work that you do, or if you'd like to play around with what all service workers can do for you, I'd highly recommend this amazing compilation of feature-wise code of service workers. So do check out the Service Worker Cookbook. It's a great place to start. And that's it from my side. Thank you very much.